Hello everyone, I am Nilima Salvi, working as Assistant Professor, Department of Pharmaceutics, Smriti College of Pharmaceutical Education, Indore. In previous videos, we had discussed about the unit number 1, Preformulation Studies, in which we had covered physical properties of the drug substances, and we had started chemical properties of drug substances. In previous videos, we covered in chemical properties hydrolysis, oxidation and reduction. After that, today we are going to start with the third chemical property for the drug substance, that is photolysis. So, what is photolysis? Photo means light and lysis means breakdown. It means because of light there is chemical degradation or chemical decomposition occurs of compound or molecule or your drug. So because of light the compound get breakdown. It is known as, the process is known as photolysis. It is also known as photo dissociation or photo decomposition. Photolysis is also known as photo dissociation or photo decomposition. After that, the photolysis is a chemical reaction in which the compound get degraded by the photons. It means because of the photons, the compound or the substance or the chemical reaction into the product takes place because of the photons or by the light. So this decomposition reactions occur and the equation for this decomposition is P, that is photon power, which is directly proportional to 1 upon lambda into 1 upon capital E. So in this formula the photon energy P is photon energy, which is inversely proportional to its wavelength. This is wavelength. So photon energy is inversely proportional to the wavelength, and this is electromagnetic waves. So this is the formula in case of photo decomposition. So after this electromagnetic wave with the energy of visible light such as UV and X-ray are usually involved in such type of reaction. It means the photon energy which is employed or which is active in this case is arises because of the visible light or by the sunlight such as UV rays and X-rays. So these are the sources through which photo decomposition occurs. So after that, the drugs which undergo light induced chemical degradation are known as photolabile substance or photosensitive drugs. Photolabile or photosensitive drugs are those drugs which are sensitive in presence of light or the drug which easily degrade in presence of light. So they are known as photolabile and photosensitive drugs. For example of photolabile drugs are riboflavin, tetracycline and chlorpromazine, etc. There are many more such kind of drugs which are photosensitive in nature. These are the some example of that kind of drugs. So in photosensitivity or in photolabile nature of drug, what happens and how we can say that the drug is photolabile, or what changes would be there into the product by which we can say the drug is photolabile or it can decompose in presence of light. So the changes would be like color change of compound or color fade process through which we can avoid or we can prevent the drugs from photolysis. First of all, how we can prevent the drugs by photolysis is that we can procure the drug or we can pack the drug by into the packaging material which is protective in nature with the light or which protect the substance from the light. In such cases, we go for the amber colored bottle, and if the strips of drugs are there, so we can pack them into cartons or outer cardboard boxes type of packaging material. So in prevention, first is by preventing the light exposure. Directly we have to prevent the light exposure of drug substance from the light. So there should not no direct contact between the light and drug. So this is the first technique of prevention. Second is that we can storage or store the product at low temperature. Third is that proper packaging. We can properly pack the material. For this we can go for yellow green containers or yellow green glass bottles, or second option is amber colored bottle. Amber colored bottle or glass container protect the drug with the light or gives light protection to the substance is amber colored glass bottle के through. After that, yellow green glass or container would give protection against the UV rays. So this was the photolysis. Next we will start with the racemization, reaction and polymerization. Start with the racemization reaction. In racemization, first of all understand that what is racemization. So racemization basically is the mechanism or method in which a conversion of optically active compound into optically inactive compound occurs. Or we can say that in racemization, what happens? It is the process of conversion by the heat or chemical change. That this reaction could take place because of the heat or chemical changes or reaction into the compounds. So in this conversion, an optically active form get converted into optically inactive form, in which half of the optically active compounds is converted or becomes its mirror image, which is known as enantiomer. And in this case, the amount or the ratio of the plus and negative forms is equal. So this is known as racemic mixture. So racimization basically conversion of an optically active substance into optically inactive mixture of equal amounts of the dextro-rotatory and levo-rotatory forms. It means there is equal amount of D and L forms into racemic mixture. So this is known as racemic mixture. Then what happens into this conversion? The interconversion of one isomer into another. It means there is conversion of one isomer into other, and this conversion can alter. What would be the result of this conversion is that this conversion can alter the pharmacokinetic, pharmacological and toxicological properties of the drugs. So these three things would be vary because of this racemization reaction: pharmacokinetic, pharmacology and toxicological properties of the drugs. After that, for example of this is that L-epinephrine. form or levorotatory epinephrine is 15 to 20 times more active than its dextrorotatory form. It means L is more active than dextrorotatory forms. Then an optically active substance lose its optical activity without any change into chemical composition. It means there is only loss of optical activity, but there would be no change into the chemical composition of the compound. Then the phenomena in which an optically active compound can racemize this substance, when it get racemized, this racemize or racimization depends on, first is chemical structure. It is depends on to the chemical structure. Then secondly, it is depend on to the type of grouping attached to asymmetric carbon. The grouping which are attached onto the asymmetric carbon will affect the racimization process. Then rate of racimization also depends on, firstly and secondly, it depends on these two things, and after this two things, it is also depends on to the presence of catalytic hydrogen, hydroxyl ion, heat and light, and solvent, then catalyst. These all are the factors which affect the racimization process. So this was the racimization in chemical properties of drug substances. After that, the last chemical property for drug substances is polymerization. Polymerization is a phenomena in which there are n number of monomer are attached to give polymer, and this phenomena or this process is known as polymerization. So again, the polymerization is a type of chemical degradation reaction, and it is continuous reaction in between the molecule. Polymerization is a continuous type of reaction into the molecule in which one or more identical molecule or monomer, they are joined to form large complex molecule, or you can say polymer. Then example of this polymerization is darkening of glucose solution is example of polymerization process. Then the next example is degradation of antiseptic formulations during storage, and aldehydes is due to polymerization. Then formaldehyde solution when stained in cold may cause formation of white deposits. This is because of the polymerization into the formaldehyde solution. So this was the polymerization. Thank you.